We're going to go ahead and get started, guys. Thank you, everybody, for coming out on, it's not Thanksgiving Eve, but it's close, the week of Thanksgiving. The fact that you all came here in person is really impressive. I'm so glad you can make it. Best part of meetups is, no, I should say the value add of meetups themselves is the in-person interaction that happens before the presentation or after the presentation. The presentation just gets you here. So, not that your value's not added, right? People come because they find it interesting, right? Right? That's what I'm saying. The presentation's interesting, you come, and then you get the value, you talk to the speakers or each other after. So, we're so glad you could come. I'm Mariah. I organize this meetup. I've been doing it for 7 years, almost 8. So we've been here for a minute. If this is your first time here, we do have a Slack community associated with this group. You can go to our website, forgeutah.tech. There is a link right on the page that says join Slack. You join Slack, and then you join all the fun channels. There's a machine learning channel, there's an AI channel, there's an anti-AI channel, and that one's fun. I don't know, I find it great that it exists. But if you're interested in Kubernetes or home labs or just anything, there's any channel that you could possibly want to join. And it's the best way to get a hold of me. I'm always on Slack, so you just ping me and whatever. We are not going to have a meetup next month. That's the biggest announcement. We're skipping December because it's the week of Christmas. We will be back in January. We have a speaker lined up for January, and the topic will be tool calling. So it's Introduction to Tool Calling 101. I don't know. We'll figure out the title, but it's tool calls. Everything you would ever want to know about tool calls, and so that'll be in January at the normal location down at Weave. And I think that is it. We're so glad that Hubbert could come and speak today. This is the last meetup I'm running of the year, so you get to finish out the year for me.
Awesome.
It's going to be great. So give him a round of applause. We'll let him introduce himself and give you guys a nice little presentation about it. Was AI, self-hosting business, and secure. Oh, I remembered. I just copied and pasted that.
Good job.
There you go.
Yay.
How
do you do this?
Clip right on there. Yep.
All right. Hi, y'all. I'm Hubbert Smith. I'm the founder and CEO of I4Ops. This is not a vendor pitch. What I'm going to suggest is that how to do confidential, secure AI for businesses. The premise, and I'm going to flip back and forth between this, the code and the, I've got a PDF that I'll share with you. A little visual aid. Oops, that's not it. I know it's here. Of course, I thought I was prepared. Bear with me, guys. This works. That's the Acrobat? Yeah, it is an Acrobat. That's the one that I don't want. I want this one. There it is. Look at you. All right. So the point here is that we're doing applied AI for business. Invariably, if you're doing applied AI for business, it's got confidential data in some form or fashion. So you can't really, in good faith, plug it into ChatGPT and say, oh, ask me questions. So there's a couple of moving parts here, and I'm going to offer an early career moment, and then I'm going to get into it. I did bring running code, so hopefully that's interesting. A long time ago, I was with NCR, and this was back when NCR had Teradata. Teradata was one of the anchor folks that did data warehousing. The main customer for Teradata was Walmart. Back then, Walmart was just another department store. They were like the 7th largest department store in the world. Kmart and Sears were the largest department stores in the world. Walmart used this data warehousing system, and there's a point here that relates to this. They had a data set that was their demand, and fundamentally it was supply and demand. Demand for them was cash register receipts. People that shows demand. They put cash on the barrelhead. And so they had this rolling database of cash register receipts. Now, obviously, that's dynamic because you have new data every single day. They had a separate data set that was inbound inventory. So they had these trucking centers, and they would bring in pallets of tires and pallets of motor oils and pallets of hula hoops and all the stuff that Walmart sells. And what they did with this data warehouse was they merged those two, and they mapped limited inventory to where it would do the most good. And they quite literally put Kmart and Sears out of business. Those companies are gone. By the way, Kmart had the same system. They didn't use it well. Anyway, so lots of good stuff has changed since then. Back then, all of that stuff cost millions, millions in hardware, millions in software, millions in training, NCR built an office building in Bentonville. So they had a data warehouse that came with its own office building. Now you can get the software pretty much for free. You can train yourself pretty much for free. I did. You can run it on pretty modest hardware. So what I'm suggesting is now we can have this same type of an approach for business data, for multiple data sets, that's available to small and medium businesses. So let's get into this. Self-hosted, secure AI for business. What I used was Llama. That's just one choice of many. Let's start with a problem statement. We want it to be as simple as possible, but no simpler. That's always a good thing to start with. That's a ubiquitous thing that always has worked for me. We want to be able to use AI chat interface with business-sensitive data. So it's business sensitive, so you can't just throw it over the wall to ChatGPT and say, ask me questions. You want to support multiple data sets, just like I explained with the supply and the demand data set. You want to be able to use multiple data sets. And in this example, what I've done is created a little small, I'll call it a toy application, but it works, that is about manufacturing robots. So manufacturing robots have any manufacturing facility has robots, has a robot catalog. Those robots have maintenance schedules. Those robots collect data and produce data, and that is managed as confidential data. So this example will show some robots, and it will also map the second data set is the industry requirements. So we're now starting to see, in this case, I trained it on the EU AI business requirements. The European Union has AI related requirements for data management. So I basically said, here's some data and here's some AI, and I can ask it questions of both. So support many data sets, reasonable security. No security is perfect, but putting this as a self-hosted system, managing the roles-based access control, that's reasonable security. That'll stand up in any kind of a legal situation, or most legal situations. And we want to, at the end of the day, the business value of this is to provide insight into relevant AI risk and compliance and industry specs. So that's what I meant when I said the EU AI regulation. So let me get into the code of it. So just to give you a little bit of a workflow, it's a lovely screen. I simply start off by saying I'm going to verify my setup. And all this really means is my hardware set up, and do I have the proper Python data loaded? So that was a pretty simple step. The next step is I want to do an AI pre-check that says, is Llama running? And there are two models. There's a Llama 3.2 model that is actually the Q&A, the chat model. And then there's another one, and I forget the name of it, but there's a specific model that is optimized for the RAG input. And part of this is going to be, I'll show you how I did this RAG. So I'm just going to do a little AI check here. And so You see the familiar white blocks that come up with this part of Olama. Any questions so far? All pretty straightforward? Okay, so here's where it gets more specific to the factory and to the robots. So what I did here was I said, I'm going to mock up some robot data. Just typical stuff that you would have in a factory. And by the way, it happens to align with the stuff, the data that you have to, by law, manage based on this EU AI Act and several other acts. So all I'm going to do is I'm just going to run this, and I'll show you the result. It's super simple. So it creates a bunch of robots, basically, and it will produce data that's sitting in here. So you'll see 3 chunks of data here. So these PDF files are the AI EU Act. It's just a chunk of data. I just throw it into this data folder, and we chunk it up and populate our RAG with it, with these specs. So this is unstructured data. It's a PDF. It also has some structured data. So this is the data that we just created. So we have this audit trail, a compliance records, life cycle events, maintenance records, operations records, and robots. Let's just start with that one. I'm not going to drag you through too much of it. The main event is the flow. This same flow can be used for a lot of different businesses. Chuck some data into a folder, train it with a RAG, add a chat interface, give your business users access to this business critical data that is relevant to them. So this little grid thing up here that I've got, it shows you it's a prettier, come on, dude. Should have brought a mouse. There you go. So it's just sort of a spreadsheet kind of thing. So you can see this is a pretty toy kind of application. It's got 5 robots. The robots have unique serial numbers, model numbers, manufacturers, etc. In related news, I was working with a similar customer, and they were a food and beverage customer, and they are required by and it's a domestic U.S. customer, they were required by the FDA to keep track of, in this case, it was their programmable logic controllers, PLCs. Programmable logic controllers, just a small robot. I mean, it's a thing that turns off and on stuff. It's pretty damn simple. So I just view these as just little black boxes. They have some data. They might have a lot of data. They might have just a little bit of data, but it's a black box. So PLCs, you can just substitute robot ID for PLC IDs. You can keep track of the PLC provenance of the ladder diagrams, which is the stuff that turns them on and turns them off, which is required by the FDA. And you can keep track of the provenance of the device firmware. So this is the factory stuff that comes and runs the PLCs, and those are updated periodically by people like Alan Bradley and General Electric and so forth. Again, the point is not to teach you about robotics or factory manufacturing. The point is to show you how to apply data science for these types of use cases that are business relevant. All right, so we looked at the data. We looked at the structured data. Those were the CSVs we just generated, toy data. We looked at the unstructured data very briefly. So that's these guys. This EU Act, I think it'll show up. No, it won't. This stuff is downloadable from the internet, so it's pretty easy to get as long as you know what you're looking for. Just as an aside, how I take a look at that is do that research. It's really simple research. You say, what industry specifications, what industry regulations are a food manufacturer subject to? And it'll give you a short list. This is ChatGPT, or I prefer Perplexity. Give you a list of specs. You say, explain those specs to me. Then the next thing that you do is you say, what data am I required to track from these specs? and it'll give you a list of attributes. And then you say, write me a database structure, either a CSV structure or an RDB structure, that maps to that. And then you say, plug in some faker data. Then you say, compare it to these specs. If you want to be real fancy about it, you can say, you can inject errors into that faker data. And then you can say, tell me where I'm going to run into a problem with my audit. So these are all things that business customers find super fascinating. I'm sure you don't. All right, so we talked about the AI pre-check. We talked about the data load. Now, this is the heavy part of the system. I'm going to go ahead and run it. Fingers crossed. This is the process of looking in this data folder, looking at the structured data, the CSVs, looking at the unstructured data, the PDFs, and I'm just going to go ahead and run it in the interest of time. And what it will do is it'll create a RAG. And a RAG is, the way that I think of it is, it is like a data sidecar. You're not really training the AI system. You're not retraining Llama 3.2. That comes trained. That's a model. What you're doing is making a data sidecar that allows that Llama model to use that data in a very structured way. And what's happening under the covers here is that that stuff up there, the structured and the unstructured data, is about to get chunked up. Chunking is actually a technical term, into a vector database. And the vector database that I'm using is ChromaDB. It's just what it is. No, this bottom line is relevant. One of the cool things about the way that the app works and the way that Chroma works is that it expects ongoing data dumps. So you start off on day one and you train up your database, and then you add data in day two and you say, chunk that up too. And you add data in day three and you say, chunk that up too. What you don't want is for those 3 days to be redundant. You want the incremental add without redundant records. So that's why this bottom line is the way that it is it allows you to say, no, I don't want to completely rebuild the data. I just want to rebuild the data on the new stuff. So I'm going to be very brave here, and I'm going to say yes. And I'm pretty sure it'll work. I don't know. Maybe not. Now, this is running on fairly modest hardware. It's running on my lab system at home. The system is like an i7 20-core. It does have a lot of memory. It's got 64 gigs of DDR5, which is awesome. Anybody, if you're putting together a new PC, DDR5, absolutely the way to go. Best money you'll ever spend. I happen to I once worked for Samsung, so I know of which I speak. It has a N-3 generation GPU, so it's got an RTX 2070, I think. So it actually chunked all that stuff up. It says that it loaded 10 documents. Those 10 documents, as I mentioned, were chunked. So they're chunked into 1,000, it says 972, close enough, 1,000 pieces. So this next step, you're sort of doing some pre-training for your RAG. So you can say exit and just bump out of this and don't do anything. But it's good practice to give it some typical questions just to kind of get that muscle memory going for the model. So I am going to ask it 2 or 3 questions, and then it's going to say, all right, I got this fake question. So I'm going to say, enter your question. Tell me about my robot inventory. Robot inventory, pretty damn exciting, right? All right, so it just said, it's a fake answer. Tell me about my robot maintenance. tell me about EU AI Act. All right, it's good enough for hand grenades. So now let's hit exit. So it's created an info pipeline. So far, we've created some dummy data. We've just dumped that data into literally a data folder. We have grabbed that data using this rag load routine that will chunk it up, and it's populated this ChromaDB that's sitting up here. So now it's time to use it. Now, there's two ways to use it. One way is with a Streamlit user interface, which is running on my system at home. I will fumble around and see if I can get that to run via an IP address and a port. Fingers crossed, I haven't tried this. But I also have a fallback, which is this RagChat terminal, which is exactly the same thing, except it's just ASCII, right? So, yay. All right, so this is, it says Pi, it says it's a Python program, but you have to run it like this. So I will share with you that I, as a fallback plan, did a video of all of this, and I just hit Python 3, 5 RagChat, and it just lost its mind. It just, no, you can't do this. So I was gonna, I did not edit that out. I wanted to give you the real stuff. So that should work. So what's happening is that this 192.168.1.254, there's a network URL and an external URL. 8502, I'm sure, is the port. I will just see if this works. If not, we will do the fallback to our ASCII. All right, I need a browser. We having fun yet? Any questions? This is exactly the excitement that you came for, right?
Yes.
I got to admit, this is pretty fun stuff for me. I'm wired atypically, as no doubt some of you are. All right, it's thinking about it. I have a feeling this is not going to work. Any coaching from the nerds among you? No? All right. It would have come up. Let's retreat back to ASCII land, and I'm just going to Control-C out of this, and I am going to just do this terminal and get this crap out of the way. And hopefully this will produce some Olama-looking stuff. Okay. RagChat with Olama in a terminal. Hello, Hubbert. There's the rag location. Ask your question. If I want to, I can preface this with a load, a file, or a clear, or an exit, or a quit. So I'm going to say, tell me about my robot inventory. By the way, I'm typing this very specifically, so if you said, tell me about my inventory, it would give you this really vague answer. Well, inventories are about, how much is in your warehouse. But you say, my robot inventory, and it will give you actual answers. I think. Here we go. So we can see from that faker data that we put in here that I have a Yashikawa robot with a serial number. I have a Staubli. I have some tasks lined up for that. Again, all of this is just generated from the faker data that I crammed in here. Scheduled maintenance, etc. This is one of my favorites. Stop.
Patients have caught your typo and understood what was going on.
It's a joy to behold. Explain EUA. Stop. I never use this keyboard. AI to me like I'm 6. Why not? Like a big group of countries. Love it. All right. Let me go back and do some closeout here on the fun stuff, huh? All right. So we have problem statement as simple as possible, no simpler. Insight. This is some program manager speak. I spent a lot of years in Silicon Valley doing program manager, so there's always acceptance criteria. I dealt with a lot of programmers in my past, and if you show them the finish line and say, if you can do this, you get an A, and you don't move the goalpost, holy crap, they will conquer heaven and earth. They really will. So this acceptance criteria, here's the finish line. Don't mess with it. That's kind of a big deal. But the other side of this is not only to interact in a positive fashion with the programmers, but to interact with the customer in a positive fashion. Simple. So 2 or more data sets. Any customer is going to understand that. Use in-house robot data with frequent updates. Okay, so you're probably going to have to add some sort of a pub sub, like a subscription thing where you plunk some additional data into that folder from time to time and retrain. Not that big of a deal. Demonstrable security and support for audit efforts. So your customer is going to push back on you on that and say, these audits are hard. And you guys say, great, show me an example. And then once you have an example, then you can say, all right, here's how you might fail, and here's what I can look for, and here's what I can engineer around. Modest hardware. The hardware that you saw this running on was, I put together for like, I don't know, $2,500? And so I'm saying modest hardware for a business is $15,000. That's pretty affordable, right? To do that with a check, with a credit card, and ready in 30 days. That's kind of you want to put a deliverable and a timeline. All right, so, and this is a little bit of an industry lore. So why do you want to do an AI with an internal RAG, an internal AI with an internal RAG? Why? Why? The first thing to understand is that there is a workload that is a training workload, and this is what all of the mega data centers, the big ones that use up all the water and all the electricity and that will turn the earth into a cinder, they are running training workloads. So primarily what they're doing is taking everything that was ever said on Reddit and cramming it into something like what you're seeing with a RAG. Now they're training the whole model. There's some subtle differences, but the point that I'm making here is that you don't need a gigantic data center to run AI on your own because the workloads are different. You're not running a training workload. Well, more specifically, the training workloads that you're running is microscopic. That little chunk of training data was tiny. You can run this, you can train a RAG on this with very modest hardware. So it's possible. In doing this, you have autonomous AI, meaning that you can avoid data leaks. You can provide reasonable security for your business data. And from a people standpoint, there's this whole notion of dark AI or bring your own AI or whatever. People are just kind of, in a very haphazard way saying, oh, well, I'm going to ask Perplexity or Claude or whoever. The problem with that is, first, that they're not using current business data. Second, it's hard, it's not impossible, but it's difficult to do that with multiple data sets. Thirdly, you don't have a single version of truth. So depending on how you ask the question and to which search engine you asked, and when you ask, you're going to get wildly different answers. With this one, if you can craft the prompt and store it, you're going to get the same damn answer every time. So that single version of truth is really important in businesses. It really reduces the thrash. All right, so this picture of this building was up here for a reason. I used to work in this building. This is the Samsung mothership in San Jose. Samsung paid really well, but boy, what a horrible place to work. Oh, just ridiculously bad. All right, so the reason why I put this up here was this moment kind of gave me some guiding purpose of the company that I'm working on. Maybe 3 years ago, there was a news that hit, public news, and it said Samsung's prohibiting the use of ChatGPT for workplace stuff. Prohibiting the use. And you dig around a little bit more and you say, well, why are they doing that? And it comes to find out that they had experienced a situation where somebody was using ChatGPT and plugging in some business data and saying, help me with a business report or format this. All right, that's a full-on data leak. And Samsung brings security to a new level. I did more than one business trip to them. They're 50 miles from the DMZ. It is scary how much security they have. All right, the other thing was that some firmware developer said, fix my firmware. All right, that's really bad. I mean, profoundly bad. They have thousands of people working on firmware, and the competition is so cutthroat in that particular space. So Samsung put a stopper on it. No doubt they've got a whole data center that's doing exactly what I've just described to you. But the point is not we're going to go and service Samsung. The point is that we're going to go and service a law office down the street. We're going to go and service some sort of a local manufacturing group or a local tour group that has an inventory of bicycles. This is all very doable as long as you frame the problem correctly. This one really appeals to me. Your average legal firm. All right, so confidential information. It's not necessarily subject to HIPAA. It's not necessarily government secret. It's not necessarily SEC regulated, not financial terms. Well, it can be, but not always. But you, as a law firm, would plunk your caseloads into this. And you can parse them up so that they don't pollute each other. But then you can ask it questions, and you can leverage previous experience of your caseloads in the context of your new caseload. So this is, and it needs to be secure. So this is, I think, a very useful, a very viable use case. I'm going to repeat myself just for a second, just to go back through the workflow. 2 or more data sets, I just stick them all in one data folder, both unstructured and structured data. There are some libraries that you're going to need to load, but the debugging stuff will just tell you the libraries. There's one called PDF Plumber that helps you chunk stuff up. There's some other ones. In this case, I used industry specs and I used robot data. I did create mock factory data. I explained to you how I did that. And the reason why I would want to do that is you don't want to leave very much stuff up to your customer in terms of customer imagination. You say, just imagine a spreadsheet. And they go, no, I can't imagine that. Just imagine this robot data. They go, yeah, I can imagine that. So actually mocking up the data is a real plus as you're going to engage with the customer, because it gives them a couple of steps closer to the end result. The RAG chunking, this was probably the hardest part, is to get the vector database put together. And I'm 100% sure that I fell violently short in optimizing anything, of making the queries right and making the RAG ingest good, but it works. And you can ask it questions and it gives you reasonable answers back. So there is that. So we talked about the vector database. I talked about the hardware, and I wrote down the specs for you here. my typical, I told you my dev system, but my typical system is an i7, 8 core, 32 gigs of DDR4, 2 SSDs. GPU is optional, you know. For this size of project, this is pretty easy to do. So there's a data models.py, which is the thing that structures your faker data. There's a requirements.txt, which sets up your Python environment, make sure that the right libraries are loaded. And then going back through the data flow, you have verify the setup, an IA pre-check. This one's important in that it'll throw errors at you if your Llama and Llama 3.2 and there's that other one, there's another model that's required for the chunking. So I would advise you do this pre-check, this pre-flight validation that says that it's running. Llama tends to shut off and start up at weird times. Reg load is the document ingestion. Regchat 5 is the, sorry, that's a cut and paste problem, pre-flight validation. It's what it is. It's a chat interface. There's some other things in here. There's a RAGO review. There's some domain logic and documentation and maintenance tracking, operational tracking. And that's actually a good point. This is only as good as the data that the customer throws into it. So it's really important for you to dig around and say, as part of your daily work, your operations people, what data do you produce? Get your arms around that so that you can have a good answer as you ingest that data. And the important part is to say there's multiple sources of that data. There's maintenance, there's operations meaning how many corn dogs did you make? And then there's sales, how many corn dogs did you sell? You know, there's all sorts of multiple data sets that'll come at you. And then supportability. You know, you want to be able to run this thing, move it around, et cetera. But it's a neat concept in the sense that it's available to gig workers and you know, early career folks, just like folks in the room that want to help the company they work for or help the company that they want as a future customer. Full data control. Compliance is a big thing, and when I say compliance, I mean stuff like GPDR, the EU AI Act, CMMC, SOC 2. There's a whole bunch of NIST regulations. But the lovely part about that is using this approach, you can compare the desired state defined by NIST or CMMC to the actual state, which is what's going on in your log files, what's happening here. So anyway, that's got it for me. How am I doing for time? We good?
You're doing good.
Awesome. Questions?
Yes. So if you were to put this into production, would you use Streamlit or maybe something else?
Yeah, anything else? Yeah, Streamlit has got its pluses and minuses just like anything else. Our dashboard at work is a good bit more sophisticated than just a chat interface. It's a dashboard, so it has green lights and blue lights and red lights and timestamps and other things. That's written in TypeScript. It's very possible to do it in Streamlit. I like it because it's pretty fast and pretty reasonable to use. It's not as buggy as like PySimple GUI or that other one that was before PySimple GUI. Streamlit's not as buggy. TypeScript's it's harder to develop, but it's more capable. It does more.
And what about ChromaDB? What made you choose that for your instance?
I needed a vector database.
Okay.
As
As good as any?
It's as good as any.
All right.
And there's 3 or 4 of them that'll work. Neo4j is writing the same thing. This one was free and Python friendly. So that's where that came from.
Thank you.
Sure.
For something like a law firm, what are some of like the typical customer requirements for context window size, or how many documents would they need to retrieve, and what context window size should you target?
Oh, heck, I don't know. I really don't.
Could it be like
I'd be
thousands or millions, or?
I'd be bullshitting you if I said I knew. Thousands certainly, tens of thousands, maybe hundreds of thousands. No, that give you a ballpark.
Yeah. I guess that would determine your model size and how much VRAM you'd need for the local machine.
Yeah.
Also impact your chunking though, or how big the chunk you want to bring in.
Right.
And if you're running on only CPU, you're fairly limited to small data sets as it is in this case.
Yeah. And the GPU, if you're going to go into production, you're going to need a GPU. Let's just turn that corner. That's what $15,000 was the number that I threw out there. That'll cover a decent GPU. So yeah, do that. This stuff will obviously fit with Kubernetes, and therefore you can scale it past the bounds of a single machine. But I didn't drag anybody into that because there's so much that you can do with a single machine. You know, as simple as possible, but no simpler. So if you want to talk about Kubernetes, I'll come back and talk about that. Yeah.
You said you didn't try to optimize the chunking at all.
Nope,
How much of a potential benefit do you think that could have?
not a clue. I really don't know. I know that there are optimizations that can be done in the size of the chunking and the way the chunking, and I'm sure that there are some metadata taggings and some pre-training things that you can throw at it. I don't know what they are. I haven't tried them. Reasonable? Anybody else got a good answer for that? I'm sure that I'm not the only person that's tried this.
It's highly dependent on your data, the overlap, how separable your data is into chunks. Do you want overlap? Do you want semantic chunking? There's lots of different impacts that go into that.
Yeah. Well, okay, so now my turn to ask you questions. Constructive criticism, what did I miss? Any glaring, like, oh, dude. And you're not going to hurt my feelings. I'm going to learn from it.
One of the questions I had, you mentioned is that the benefits of this is that you type in the same prompt, you get the same answer. Is that because you set the temperature to 0 or
Mostly.
Otherwise, you might have the variability of the model itself.
Yeah. Let me qualify my statement, or let me rectify my statement. If you have this system, you have OLAMA and a consistent model set and consistent training set, and you type in a prompt and you capture that prompt and you ask it that question, and then you ask it the same question another day, it's going to be pretty close in comparison to I'm going to type up that thing and I'm going to ask ChatGPT this thing and then I'm going to ask Claude the same thing. It's not going to be close. So that's the point I was trying to make.
Sure.
I guess one question I have is about scale. So
Yeah.
again, say you have like a terabyte of data.
Yeah.
That obviously can't fit in memory. Is the database,
Oh,
does it operate on disk?
Yeah.
And like,
Yeah,
how slow is it when you have?
yeah. The way that I typically would set up the storage, and I'm a storage guy, so this is absolutely my wheelhouse. I would set it up with a couple of 3 NVMe SSDs, and you can get 4 terabyte, 10 terabyte NVMe SSDs. They're not cheap, but they fit in one box. They're screaming fast. Anybody want to dive into the nuances of NVMe versus SATA? I'm happy to go there. Oh, come on.
I know, I have no. I just know that I have an NVMe thing somewhere.
That's a good thing to have.
It's somewhere.
Yeah.
Regarding what you said a moment ago about comparing the outputs between different models,
Yeah.
if you wanted to prove that to a client, you could include a section on an observability tool,
Absolutely.
like
Absolutely.
coming up with quantitative metrics to prove that you have close
Yeah.
to ground truth for the output.
Yeah, observability is huge. Thank you for bringing that up. The other thing that I will throw in there is there are some additional cybersecurity observability tools that you can bring to bear if you've got the will to do it. And when I'm saying that, I am talking specifically about not necessarily preventing infiltration, but demonstrably preventing exfiltration. The main event in all of the CMMC and HIPAA and all of that crap is keep the data in. Don't let that sensitive data out. So, you know, I think that the cyber, and this is just, I'm a crazy guy with weird opinions. This is my opinion, is that the cybersecurity industry in general is profoundly broken because they don't really secure the data. They secure the network, they do boundaries. Anyway, I'll stop preaching. Keeping the data in, you can prove it. There are ways to monitor, and you know, if you're smart about it, it does take some work, but Audit D is a pretty decent tool. Yeah.
I guess another thing, but I don't know if this is really a question or more of just a thought, but
Yeah.
it would be good to compare this vector database
Mhm.
approach
Yeah.
to, like, I know agents and MCPs. You can use those locally, and that's
Sure.
kind of big in the space. So
Yeah.
I'd be curious how a RAG on a vector database would compare to something like that, where it just kind of searches through files directly.
That's a good question. I don't know the answer to that directly. The main event there is to have your multiple data sets together so that they can be accessed together and cross-referenced together. That's the business magic of it. That's the thing that NCR taught me 30 years ago. But you know, how you do it, is it better to do it with a vector database or an MCP? I don't know. Try it. If you want to contact me, I'll try it with you. We'll learn something.
We can probably do one more question, but anyone's got one more comment.
Yeah.
I was just gonna say that with the vector database, you probably get the semantic search ability.
Yeah.
Versus searching at your, probably only looking at the file path structure to help you out with that.
Yeah.
My question is more, have you done work to figure out the right way to figure out the number of documents being for your context? So like, for instance, it looks like you have a fixed K of 5. You know, how do you know if all 5 are relevant? Have you seen much work?
I am a newbie at that. Yeah, that's a great question, and I'll know more next week. Thank you for bringing that up.
Cool. Edward, let's give Hubbert a round of applause.